Today we are going to take a look at multiplying mixed numbers using the area model strategy. So you may remember from in class, we've done some work with mixed numbers, but it was always with a whole number. So for example, we had done problems like 12 times 2 3/4. And a lot of you used the strategy where you took that 2 3/4 and you broke it into parts and you did 12 times 2, and you figured out that that was 24, and then you also found out what 3/4 of 12 was using one of your strategies there. So like 12 divided by 4 is 3 times 3 is 9, and then you would add those pieces together and get a value of 33 for this problem. That is a great strategy to use when you are multiplying a whole number by a mixed number. But what we want to look at today is what starts to happen when we're multiplying a mixed number by a mixed number. So one way we can do this, like I said, is through the area model. So with the area model, what you have to think about is we're basically taking a rectangle and we're going to break it into parts. And if you remember from elementary school, area, and the reason it's called an area model, is always equal to like length times width or base times height. So we're essentially finding the space that is taken up by this rectangle. If we start with a problem like 2 3/4, and we're going to multiply it by 1 1/2. With the area model, we're going to take each of these two mixed numbers and designate them to a side and kind of break up this area into smaller parts so it's easier to work with. Now, I have a longer side and a shorter side on my rectangle, so I'm going to use those accordingly with my mixed numbers. So I'm going to take my longer side, and what 2 3/4 is it's really the value of 2 plus 3/4. So I'm going to kind of break it up that way. Now it's not perfect in how I'm splitting it up. I'm mainly doing this just as representation. So now what I'm saying is that this length right here is equal to 2 units. This length right here is equal to 3/4 of a unit, obviously not to scale. And I'm going to do the same thing with 1 1/2, but on this side. So here I have 1 plus 1/2. I'm going to go ahead and split my rectangle that way as well. As you can see, the rectangle has now been split into 4 parts. So I have a smaller rectangle here, one here, one here, and one here. And each of these smaller rectangles has its own smaller area that is a part of the larger area. So what I like to do then is just multiply and find the area of each part. So for example, the area of this piece is just 2 times 1, or 2 whole units. Then if I move to the right, this one becomes 1 times 3/4, or a value of 3/4. If I move down, I can see that I have 1/2 times 2, and 1/2 of 2 is just 1. And then in this lower right hand corner, I'm going to have 1/2 times 3/4. And we can just use our procedure that we use for multiplying fractions and multiply across, and this becomes 3/8. Our next step then to find the area of the larger rectangle is just to add up the smaller pieces. So this becomes 2 plus 1 for these 2 parts, which gives us 3. And then I have to add 3/4 and 3/8. Now before I get to that part, remember that fractions have to have a common denominator. which is like a common multiple. So for 4 and 8, one of their common multiples is actually 8. So I'm lucky here in the fact that I'm not going to have to change my eighths. I can actually leave this as 3/8. But now here, I'm going to multiply each of these by 2 because I want to show that eighths piece. So now this becomes 6/8 plus 3/8. And if you remember from adding fractions in elementary school, the 8 stays the same. 6 plus 3 is 9. Now 9/8 is actually an improper fraction. So when I do this, 8 can go into 9 one time with 1 left over. And now I'm just going to bring these last two pieces together. So I'm going to take 3 plus 1 and 1/8 for a total of 4 and 1/8. Meaning, if I go back to my original problem, that 2 3/4 times 1 1/2 is actually the same as 4 and 1/8.